Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. As large language models, and we should also throw in reinforcement learning and maybe even a few other things, as we keep pushing the limits of what these tools can do, we find ourselves in need of more and more difficult challenges for machine learning and artificial intelligence. They've beaten us at chess, checkers, and Go. They've beaten us at Jeopardy and a variety of video games. Yet none of them come anywhere close to passing the Turing test when conducted in a proper way. So one very borderline area I'm keenly interested in myself is the degree to which large language models can exhibit theory of mind. Theory of mind is an ability. I've got it. I think you've got it too. It's when I, as an agent, don't treat you like the environment. You're not like the sun that goes up and down whether I have anything to say about it. You're another person of agency, and my interactions with you will reflect my understanding of that. One of the best parts about this topic is you and I can both go engage as experimenters. Talk to the large language models you have access to and assess the degree to which you think they have theory of mind. I suspect as it stands today in 2023, you'll find them passing some tests. They don't have a complete absence of this property, but they certainly don't pass it the way you and I do, at least not today. We get into the definitions and explore this topic in great detail in today's interview.
I'm Tomer Ullman. I'm an assistant professor at the Department of Psychology in Harvard. I got my PhD in computational cognitive science at MIT, working with Josh Tenenbaum. Some of your listeners might know the name if they're into AI and data science and things like that. And after that, I did my postdoctoral research at the Center for Brains, Minds, and Machines at MIT and Harvard. And yeah, I've been a professor since 2019, focusing on computational modeling and development and intuitive theories. So kind of what we all know about the world kind of without having to think about it.
Well, we're getting to a place where I think ideas from psychology and computer science might meet in the middle. Historically, I wouldn't have thought that was the case. What's the current level of scholarship on the sort of Venn diagram of these fields?
Ooh, I hate to push back on the first question already, but I think these
Please do.
I think these two fields have actually had a ton to say to one another ever since their inception. Not only psychology and AI, but including development, which is the particular topic that I'm interested in, the intersection between cognitive development and AI. I agree that on the face of it, it seems kind of funny, like what do robots and babies have to say to one another, right? But I think these two things go back before even the terms AI and cognitive science and cognitive development were even around. If you look at Turing's original paper on computing machinery and intelligence, right? Turing, Alan Turing. I'm assuming I throw out Turing and people know what I mean. So in the original paper of Computing, Machinery, and Intelligence, where he introduces the Turing test, right? Mm-hmm. And he says, I propose to take up the questions of whether or not machines can think, and he replaces it with the Turing test, and he defends it, and people know the Turing test in that paper, obviously. But he also says, after dispelling with a few objections to whether or not this is a good idea, he says, well, how could we pass this test? And his own proposal was, let's build a child machine, right? Let's not try to build an adult intelligence. Let's try to build a child machine. And that raises the question of, well, what should a child machine know, right? What should it come into the world knowing? How should it learn the other stuff? So even before we have the terms, like this is the 50s, right? The cognitive science was not even a term. This is before the cognitive science revolution. It's all behaviorists and things like that. But even then we can see that Turing is asking these questions about cognitive development and offering up some answers. And you see that, right? And that's not the only time, right? This isn't a historical oddity. In the 60s, like when AI was a field more prominently and people thought that maybe what AI is these first order logical rules, right? That was in conversation with people in cognitive development and psychology and cognitive science, right? These fields have deeply influenced one another back and forth, right? Ideas from cognitive science made their way into AI right from the beginning and ideas from AI, because it's really the same question. It's what representations do we want to build in to these machines to have human-like intelligence, and how do they learn the rest, right? So representation and learning. These are both normative questions for AI people. These are empirical questions for psychologists. What do we actually have when we come into the world? How do we learn the rest? I think it's not surprising that these fields have had a lot to say to one another. But anyway, sorry, that was like a rant pushing off of the first question. But I take your point that like it does seem like it's having a moment, right? So these fields have always had something to say to one another. But I think you're right that they've like been moving further apart and closer together over the years. And I do think that like the last few years have seen this kind of whatever the term is, like they've been coming together more and more, is my sense as well.
Well, if I were to rewind to the 50s and read Turing's paper, the idea of making a child machine is very appealing to me because children have a pretty good track record for turning into adults with little guidance. In the same way, if I was trying to engineer a artificial sunflower, I'd probably make the seed and plant the seed. Do you think that analogy holds up for the path we're currently finding ourselves on?
No. Well, depends which path, right? There's multiple conversations happening right now in the field of AI and between AI and cognitive science and between AI and neuroscience and between AI and cognitive science. And gosh, we can't agree even between the fields. Sorry, within the fields. So also between the fields. I think there's multiple paths right now. And I think some of them are the ones that I am more drawn to. And, because of my own biases and priors and things like that, I find myself thinking that they're kind of the ones that make more sense. I think that if you mean the current path of AI in the sense of large language models and things like that, let's just talk
Sure,
about
yeah,
those
yeah.
for a moment. I don't think that that's the path of let's think about what children know, what they come into the world knowing, and how they learn the rest. I don't think that that's true. I think it is a little bit what Turing had in mind about children originally. So again, not that Turing was a genius, but we didn't know a lot about cognitive science at the time. So again, in that paper, he says let's build a child machine. Presumably, the child is like a blank notebook, right? Like you buy it from the stationers. It's got blank pages, and you fill in the rest through reinforcement learning. He didn't use reinforcement. He meant that. He didn't use the term exactly, but he kind of describes positive and negative reinforcement. He kind of says let's look at children. They start with nothing. They learn the rest through reinforcement learning. I agree with the general statement of let's start with children, except now we have 70 years of cognitive science and cognitive development. We don't think that children start like blank notebooks. We don't think they just learn through reinforcement learning. So I agree with the high level point he was making. I don't agree with the specifics. But then again, I think that multi-billion-dollar corporations are following the original, the original blueprint of let's start with nothing and let's try to, learn the rest from data somehow. So I think they are in line with the original vision. I just don't think that they're in line with the current understanding of how children learn.
Well, one property we're definitely interested in seeing if machines can develop is a theory of mind. Before we get into the question of have machines developed it, would you share some background on what theory of mind is and the degree to which one can measure it?
To take a step back for a moment, and by the way, everything I'm saying here is there are arguments in cognitive science. So the things I say, some people listening to this from a background in psychology and cognitive science might be like, that's not what that means. Okay, we can argue about it. That's fine. So just to highlight that, I think I'm giving a pretty standard spiel. First of all, I think there's something that's a little bit not contentious, which is just the empirical fact that people attribute mental states to other entities. So we look at some entities in the world and we attribute mental states as the driving force behind their actions, whether to people or amoebas or dogs or things like that, right? We see things moving in our visual field and we say, oh, why did they do that? Why did John do that? It's because John was feeling that Mary was being paternalistic. And he was very upset that Mary was being paternalistic. So he lashed out, and that's why he did the thing that he did. And I'm referring here to things that are going on inside this person's head that I don't have direct access to, their intentions, their desires, their beliefs, the relationships that they have to other people. And I do that to other things like the dog and the amoeba and things like that. I attribute to them goals and intentions and things like that. So people do that that's not under discussion. That's just an empirical fact. And the fact is that we do that very quickly and consistently, and we do it from birth, basically. So we can see that even pre-verbal infants seem to treat objects and agents differently and seem to expect that agents, right? That's just fancy talk for persons, I guess. That's the standard term. They treat agents as having intentions and goals and beliefs, and they expect different stuff from them. So that's an empirical fact. It's not much under discussion. What is under discussion is how does this work, right? What are the people are doing this, and people are kind of like computers. I mean, I know shots fired for some people maybe, but people are kind of like computers, and the question is, okay, what programs are they running to make these judgments, these fast, automatic, consistent judgments that seem to be there from very early on? And then you get arguments, right? How do people do this? And I think, and by the way, I think it's already an interesting question, right? We know that we can recognize stuff, right? I look at this mug. Tomer is now raising the mug, and he's looking at the mug and saying that's a mug, right? How do we do that? We don't know, right? We presume that V1 is to V4 somehow solving that, and we can't just introspect, right? You don't just introspect and realize what you're doing is convolutional pooling, whatever, right? We need some hard science to figure that out. So similarly, we know we do this stuff, but how do we do it is there's an argument. And going back at least 50 years, people have proposed like, okay, maybe a way that we do this that is without we have a theory of mind. Okay, so theory of mind is already a proposal. Which is not the only proposal out there, but it's a proposal that the way that we do this is that we have a theory in the same way that scientists have theories, right? Scientists look at the world and they propose that there's these underlying hidden variables. We see, our machines go bleep, bleep, and we say, oh, maybe there's this thing called electrons. And there's this thing called the electromagnetic force. I wonder, and if we assume that there are these things that we can't see, that makes sense of our observable data. And similarly, the proposal is that maybe people, when they see other people act, they propose that there's these things that they can't see, like beliefs and intentions and desires and goals, and that's the underlying hidden variable that's driving the observable variable of action. That's a proposal. It's not the only game in town, but that's the idea. Like, we have a theory. Just like scientists have theories of electromagnetism, we have a theory, and the theory is a theory of mind. I think that you have a mind, but I can't directly observe it. So that's a proposal that's been around for like at least 50 years, right? Maybe more. And then you can ask, like, okay, well, how, you can ask, like, okay, well, what is that computationally speaking, right? Like, I want to now build a machine that has theory of mind, and you just gave me kind of a basic roadmap, but how do we actually build that? And there, I think that there's been like a big, big push in the last 20 years of putting some computational meat on the theoretical bones. And there's been a lot of work by, leading people like Josh, for example, Tenenbaum, and Chris Baker. And there's been a bunch of people pushing this, Julian Jara-Ettinger, where they've been building like computational models of this idea. And, myself included, but I inherit from that tradition. But then, of course, people ask, like, well, how would you find out if this is true? How would you find out if people have this kind of thing? If other animals have this kind of thing, when does it develop? When does it start, right? And so one of the principal tests that have been proposed for this thing is like, well, if I think that you have a mind, that your mind might be different from my own, right? There's like maybe a basic thing that I do is just like I know stuff about the world. And so I just assume that you know that stuff about the world. That's not really a theory of mind, right? That's just like all I need to do is copy paste what I know about the world and paste it onto you. That's not a theory of mind. That's just like another way of getting by in the world. To really show that I understand that you have a mind, maybe a killer test would be to show that I know something about the world, right? I have a certain state of knowledge, and I understand that you know something about the world that isn't the same thing that I know. So I understand I can keep around for you that you have a certain belief about the world, and that belief is a false belief. It's not true, or at least as far as I'm concerned, right? Like, I know in the box there are biscuits, and I know that you think that in the box there are flowers, and that's a false belief. So how can we test that? And there you get these like classic studies of a particular aspect of theory of mind, which is false belief, like the Sally Ann test that I'm sure we'll get into in just a moment. So I'm just leaving that out there without explaining it further. But just to say, so then you get these tests, and these tests show that like children under age 3 don't pass it, and over age 4 they do pass it. And sometimes you get these conclusions in the literature like, ooh, 3-year-olds don't have theory of mind and 4-year-olds do. No. Well, no. The 3-year-olds don't seem to behave as though they understand false belief. And the 4-year-olds seem to understand that people, they do understand people can have these false beliefs. But for me, like that, we have evidence that children under a year seem to understand intuitive psychology in the sense that they attribute to other people goals and intentions and things like that. So if that's what you mean by theory of mind, maybe we should be more sparing. Maybe we should say, like, people have an intuitive sense of psychology. They have an intuitive psychology. And even children under 1 year old think of agents and treat agents differently and things like that. Already there are these behavioral tests for checking, like, do you treat agents and objects differently?
I would love to unpack some of those tests. Are there universal standards, or do people kind of just create them as they go?
There's been a bunch of proposals out there over the years, but the ones that have survived the test of time are the ones that seem to correspond to other stuff and that seems to agree with other things that we know. So, for example, some of the standard tasks for when you can ask things verbally is to show children and adults and animals, with animals you have to create a non-verbal situation, but to show them a situation in which an agent, a person, let's say, okay, let's just go through the Sally Ann task for a second, and I can talk about the baby stuff maybe later. But in the standard Sally Ann task, you show the children or whoever you want to test a particular person, say Sally, and Sally has a ball that she really likes, let's say, and Sally puts this object that she likes, the ball, into a basket. And then she closes the lid of the basket and she leaves the room. After she leaves the room, and without Sally knowing, Anne moves the ball from the basket to something else, let's say a treasure chest or something like that, and closes the lid on that treasure chest. And then Anne leaves, let's say. So then you ask the child, like, where is the ball right now? So first of all, check their understanding of the world, right? They can keep track of objects in working memory, and they can answer correctly that the ball is now in the treasure chest. So they can validate that. But then you can ask them, like, where will Sally look for the ball when she comes back? And now you and I can answer that she'll look for it where she left it, right? She'll look for it in the basket because she didn't see what happened and she has a belief, and we can say that she'll act on that belief. Standard, almost obvious. But 3-year-olds say differently, right? 3-year-olds say that she'll look for it. Listeners who haven't tried this and have access to 3-year-olds, please try this with them. Like, it's a lot of fun. And the fun thing is, by the way, that both 3-year-olds and 4-year-olds will like be adamant about where they think that Sally will look for it. Like, obviously she'll look for it in the treasure chest, or obviously she'll look for it in the box. Like, what do you want, right? They'll be almost surprised they're even asking them that question. It's so obvious. That's a very standard one, for example.
Are you a software engineer looking to make an impact with one of the world's premier data and technology companies? Well, you should look into Bloomberg. Bloomberg is building the world's most trusted information network for financial professionals. And right now, they're looking for engineers to join them. You'll be part of a team that builds and delivers tools to help the world's leading business and financial decision makers surface relevant information in an ever-changing ocean of data, so that they can act quickly on it. Their software engineers build solutions that are relied on by more than 350,000 financial professionals, using them to make critical business decisions. Bloomberg believes in using the right tool for the job. Their stack includes C++, JavaScript, TypeScript, and Python, all languages I love. The company is committed to building a diverse workforce full of fresh perspectives. Finding your new career can be hard, but if you find the right company, it can be rewarding and fun. So if you're in the market or just thinking about what your next move might be, learn more about this opportunity by visiting bloomberg.com/careers. That's bloomberg.com/careers. It seems like behind the scenes, I could write out some sort of, first order logic statement of inferences here that, Sally knows that's not a public space, so people aren't just randomly moving. Sally is unaware that I think it was Anne came in and had motivation to move the ball. I kind of did a lot of those things in the background without even recognizing I did them. Do most analysis of this type of work break it down in that symbolic way, or how do you methodologically look at it?
That's a great question, and I think it speaks to the gap between the empirical experiments, the verbal descriptions of those experiments, and how hard it is to then turn it into a model. So again, we had decades of people just working on these empirical experiments and then varying them in different ways. What if Anne is in the room at the time? What if Anne is in the room at the time and Sally sees what Anne is doing, even though Anne doesn't know that Sally's there seeing what she's doing? And what if, right, like people spin out like a bazillion different variations on these things to check if it's about perceptual access and if it's about common knowledge and if it's about common ground and things like that. But then there's still the question, right? Like, and then you have these like English level descriptions of, oh, what seems to be happening is that Sally has a belief, which is a probability over state of the world, and then there's perceptual access for that. Da, 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 da. Right. But, by the way, the da 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 is not meant to like. This is hard work. Like, this is decades of work and things like that. But what I'm trying to point at is that then, like some of us who are interested in computational modeling and believe this stuff and understand that this is like hard won knowledge, still they need to take those English sentences and turn them into a program, where what we want the program to do is to either take in those textual descriptions or see the scene, or do both, right? Take in the scene and the textual descriptions and come up with the same inferences. And then you kind of hit like, well, okay, how do I represent that knowledge, right? Do I consider it as like, yeah, as you're saying, like maybe it's first order logic, or maybe I don't want to exactly say what the representation should be. Maybe I should throw it all into some sort of modeling soup, and the model should come up with its own representations. Or maybe, and this is the thing that like some of us have settled on in the last 20 years, maybe what we should do is invert a planning model. And I can say more about that, but that takes some unpacking. But I guess maybe like let me close that by saying like there are disagreements about that, and there's a gap of how do you then turn this thing that we believe in into a model that can actually do it.
Well, before we jump a little bit more into the machine learning or machine intelligence, I guess, side of it, One quick, I guess, wrap up point. Obviously, I think we would agree adults have theory of mind. Sounds like maybe there's some debate about when children get it. You'd mentioned animals. What's the consensus about animals having theory of mind?
Oof, I don't even know that there's a consensus on adults having theory of mind, to be honest. So
Okay.
I no, honestly, like that. So again, if we take that, if we what's not under discussion is that adults look at stuff and attribute and seem to attribute verbally mental states to things. But do they do that by having something like a theory with utilities and goals and things like that? That's not the only way of doing it,
Hmm.
right? Like suppose for a moment that you see someone coming up to me and doing this, right? And it's like that was Tomer slapping himself. For those of you who are listening, and you might be like, and I ask you, like, why did he, like, would you say that they're friends or enemies or something like that, right? And you say, I think they're enemies. Now, do you need to have a theory of relationships and goals and utilities and probabilities and things like that? Or is there something much more fast and bottom up? In the same way that you can recognize cats by like these fast bottom up features, right? So maybe they're just like movement visual features that can directly map between the visual scene and the verbal statement. These guys are enemies, or this guy must be really mad at Tomer or something like that, right? Like you don't need to do a lot of sophisticated calculations. Maybe it's just like very simple visual heuristics or something like that. So there's still arguments in the adult literature as well about how adults do this. And it becomes important to your question about animals because I think a lot of the people in the animal literature rightly are very wary of, if we think that there are multiple ways of solving a particular problem and we just look at the behavior, right? And we say, like, okay, this input output behavior could be explained by multiple algorithms. Which algorithm do we think that this thing is implementing? I think a lot of animal people are rightly saying, like, let's think about the most sparing algorithm possible, right? Like, let's not attribute to the animals because we know that we do this, right? Like, this is why theory of
Yeah.
mind is so mixed up with this. Like, we tend to attribute to other agents all of these sophisticated things, but we know that we do this wrongly, right? Like in some cases, I look at amoebas and I say, oh, the white T cell is trying to chase the amoeba and wants to destroy it. The white T cell doesn't want to do anything. It doesn't have a goal. And we do this with, like, I don't know, we say like the electron wanted to break free from the containment or whatever. Like it doesn't want anything, right? It doesn't have goals or beliefs. I just do this. So we need to be really, really careful when we do this with animals, right? Not to say like we do this intuitively, say like my dog wanted the biscuit, but someone in animal literature would be like, well, I don't know, like saying it wanted something is like we over attribute it. So saying that the dog understands theory of mind or things like that, you're in dangerous territory. But we do. So you can run something like the Sally Ann task on chimps, for example. Well, you can run it on animals. I'm not an expert, so please put an asterisk next to everything I'm saying next. I think that the current consensus is that a lot of our not non-human animals do seem to treat objects and agents differently. So they are at the level of, say, pre-verbal infants and being able to track that other agents have goals and will act to achieve those goals and will plan around that. And that's a pretty minimal version of intuitive psychology. It doesn't include the notion of false belief, but it does include the notion of goals, for example. And even with chimps, you can run the Sally Ann task on them. And for many years, the consensus was that they don't get it. And so the idea was that they don't have false belief, from which you might conclude that they don't have theory of mind. I think that the consensus these days is that a whole bunch of non human animals can track the fact that there are agents and they're different from objects and that agents have goals. Whether they have the understanding of false beliefs, I think that some chimp researchers would say that we've shown at least that much. But I think that this is still hotly debated. And if chimp people want to take it up with me, I bow down to whatever the latest research says on that.
Well, certainly correct me if I'm wrong if I get this one wrong as well, but I think historically, I guess depends on what you mean by historically, but historically, no one would have claimed machines had theory of mind. But presently, there are people making that claim. There have been some profound advancements recently in large language models, not necessarily towards theory of mind, but maybe it's a question certainly worth asking.
Oh, yeah.
And I guess, yeah, just more of a statement than a question. Where are we at right now in 2023 as we record this?
Ooh, and we should probably say like it's May 2023
Yeah,
because I
maybe,
don't know, by December we'll have like GPT-12 or something. I don't know.
right.
But this is maybe just going to take up the next 30 minutes or something
Sure.
as we unpack this interesting point. First of all, I think it's a question worth asking, to be clear. Like, I think it's really interesting and worthwhile to ask whether machines have quote unquote theory of mind. And I think that there are various ways of assessing that. It's important for me to state in what comes next that I'm not a mystic when it comes to AI. I'm a skeptic about some of these things, but it doesn't mean I think that ultimately theory of mind rests on certain computations. These computations can be implemented in machines, and I see no reason why, in principle, machines can't have theory of mind, just like that we can build in other things that machines can do, or they can learn, or things like that. I see no barrier in principle for machines picking up this stuff. I think that we should just adopt a somewhat skeptical stance for a lot of these things. I also don't think that we have no idea of what theory of mind is in people, right? I mentioned that, like, in the last 20 years, there's been a lot of work on that in people. And I think that, at least in my corner of computational cognitive science, a consensus view has emerged on what the algorithm is that is implementing theory of mind, at least in adult humans. And so the question for me then becomes not like there's this ephemeral nothingness and the only thing we can do is point to machines and say, like, no, 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 no. But it's more like we think we kind of understand basically what the algorithm is for theory of mind, with lots and lots and lots to still do, to be clear. Lots of work to still do there. But I think in broad strokes, we kind of have a proposal for what that is. And so it then becomes a question like, okay, for this given model, if we built it in, then I think I would be happy to say, like, this thing has the basic understanding of theory of mind. And if we didn't build it in, like with these large language models, I think we can ask, did this thing learn this algorithm that I would call theory of mind? And given what I know about, how these things work and are trained and things like that, I'm a priori pretty skeptical that it's learned anything like that algorithm. I'm not a complete skeptic in the sense that I think that it's impossible that it learned it, but I think that it's unlikely. That said, I'm neither unique nor universal in the skepticism. So when I say not unique, I mean that I think that, so yes, about the lay of the land. I think the lay of the land is that there are a whole bunch of people like me in the sense that they're skeptics. I'm not unique in being skeptical. I think that there are people like, certainly Gary Marcus and Ernie Davis, but also other people who do computational cognitive science. I don't mean to put words in their mouth, but I think, using my simulation of Josh Tenenbaum and Julian Jar Edgar and other people in the space, they would say, like, I think they would look at this and say, not good enough. A recent paper just came out yesterday by this group, including people in the Allen Institute of AI, who I have a lot of respect for. I think this was led by Natalie Shapira, and this includes a bunch of heavy hitters like Vered Schwartz and Yoav Goldberg and Martin Sapp. Sorry, I'm not pronouncing the name correctly. Martin Sapp, Yejin Choi, and some other people that I'm missing, and I'm sorry if I'm missing the names, but coming to similar conclusions. So I'm not unique in my skepticism. Neither am I universal. There are certainly very smart and clever people who are thinking that maybe this thing did develop theory of mind. Why not, right? So I think that there's no consensus at the moment on this stuff. Yeah.
Well, there are ways to test. For example, like the basketball move to the treasure chest example we gave, I'm vaguely aware, even though I couldn't name one, that there are certain corpora out there people have built up, maybe not big ones, but 100 such examples, let's say.
Yeah.
Those could be the evaluation data set against some of these language models.
Yeah.
Have we made progress in those sorts of tests?
It depends what you mean by progress. In some sense, obviously, yes. If we measure things just by purely input-output and how well we're doing on like train and test splits and things like that, I think we've certainly made progress. We made progress on a whole bunch of stuff in the last 10 years, right? And that's real and meaningful and serious progress, and I don't mean to poo-poo it. But there's another way in which this progress has also been kind of in the wrong direction. Or I don't think that we've made a lot of progress on generalization. In fact, I think that we've been stuck in the same loop for the last 10, 15 years, partly because of our fixation on these benchmarks and things like that. I'm not knocking benchmarks. Obviously, we want benchmarks. Obviously, these have been like very useful for measuring progress and checking our progress and things like that, but they're fundamentally behavioristic in a way that they don't make recourse to the algorithms that you use to solve this benchmark. And in that sense, by the way, we're back to the Turing test, because the Turing test is primarily behavioristic. It says, like, look, here's the input and output condition of this test, right? Like, you need to carry on a conversation for X minutes with this entity, and by the end, you need to like say whether it's a human or not, and we'll check you against whether it's a human or not. And it makes no reference, or at least some version of the test makes no reference to what algorithm you're using to solve this. And there's always a very dumb algorithm that can solve any task, right? Like a lookup table. And this is the point made by 1980s paper by Ned Block, right? Saying like, look, I could construct a lookup table to pass the Turing test. And if you look at that lookup table and you say that's not intelligent, then surely we care about the algorithm. So similarly here, right? Like there's moving on the benchmarks, and we get like 60%, 63%, 64%. So we're moving up. But in terms of generalization, I'm not sure that we've made a whole lot of progress with some of these things. So I think, by the way, at the same time, there's been a lot of progress on the stuff that I care about in computational cognitive science. It's something that we call inverse planning. I think there's been a ton of progress in the last 20 years on this stuff.
Could you expand on what inverse planning is?
In a way, it's just basically the original idea of theory of mind, right? So the idea is, I think that you have utilities I think that you have desires and beliefs, and I think that those desires and beliefs are driving your action. So how do we turn that into a model? The way that we turn that into a model is to say, like, look, let's think about the forward problem for a moment. Okay, so the forward problem is, you give me a desire and a belief, and I need to generate action. That forward problem is the problem of robotics, right? Like, you are giving the robot a utility, a goal, and a belief, which we formalize as like a probability distribution over states of the world, the transition function, stuff like that. Given that input, you need to generate a sequence of actions. I don't want to do it for you, right? Like, you need to drive. Your goal is to get me to the airport. That's your goal. And your belief is whatever the probability state of the world is, right? So generate me a sequence of actions to get me to the airport. That's, the input is utilities and probabilities. The output is actions. And that's the main problem for planning, decision-making, economics. People in neuroscience have thought a lot about planning, right, on both the human side and the AI side and things like that. Okay, so that's a forward problem. Now, the inverse problem is just invert that, right? The input is actions, and the output is now hidden variables. Like, what is the setting of utilities and probabilities, the posterior distribution over utilities and probabilities that makes the most sense given that action? So it's a Bayesian inference, right? Like, conditioned on the observable actions, generate a posterior over beliefs and utilities. And how do you do that? You invert a planning model. So you assume that other people are working according to a planning model. Maybe they do, maybe they don't. But then once you assume that they work that way, you can invert that model. And so running with that idea for the last 20 years, I think we've made a bunch of progress.
If I follow that correctly, I think I might have different hypotheses about another person. Like the person that in your example earlier that came up and slapped you, are they your friend or enemy? It could be a prankster that just goes and slaps everyone.
Yep.
That's one hypothesis.
Yep.
But I get more information. I can update my beliefs about, do I think that person has theory of mind or what's going on? Is there a strong methodological approach to how to integrate new information?
Yeah, absolutely. There's standard Bayesian updating, right? There's Bayesian updating both in the sense of like what happens with the data and what happens with the priors, right? We could have certain priors over people and relationships, and we could get some data and link those two together. I don't mean to like hand wave that this is sort of easy, right? Like, it's not easy, but it's not easy for people either, right? There's like a reason why when you go to coffee shops, right, and you'll hear people sort of arguing. What are they arguing about? They're not holding up, I keep using this coffee mug, which means nothing to your listeners, but I'm holding up a coffee mug and saying, like, you don't go to a coffee shop and see people like, how much do you think this weighs? I think it weighs 150 grams. Well, I think it weighs 180 grams. Well, what they argue about is like, why did John do that? And one of them will say, well, I think it's because John didn't realize that Mary didn't want him to do that. And the other person's like, nah, John knew what Mary wanted. John, right? Like, and so, in the business of psychology, like, there's been, decades of research on this kind of stuff. But a lot of it is just like, yeah, I think even if we build a super machine, the super machine will have a difficulty with this thing, not because the fundamental algorithm is wrong, but because the space is just a very high-dimensional fractured space, right? The space of intuitive physical reasoning is relatively agreed on. The observables lead to the posterior pretty easily. There's pretty much a big probability of mass on the single answer. In the space of intuitive psychology, it's just all over the place, right? Like, you could say, well, if I introduce like a little bit of more information about John, and suddenly you think something else. Or if you have experience that's different based on something that you know from when you were 10 years old, you'll think differently about the situation. That's not a quote unquote problem for this kind of model approach. It's just another bit of data that we need to account for.
Yeah.
The fact is that the space is shattered, right? And now we want models that can account for it. And I think that that's not an in principle problem for these models of theory of mind.
Well, in your recent paper, Large Language Models Fail on Trivial Alterations to Theory of Mind Tasks, you're responding to some earlier research that I guess I could describe as hopeful. It showed that maybe there was some theory of mind present in ChatGPT, I think 3.5. But could you tell me a little bit about your attempts to reproduce that experiment?
Well, to be clear, in terms of reproduction, you can reproduce the findings. Professor Kaczynski from Stanford has made all of his data and code and things like that publicly available. You can just download it and rerun it and just get the same result. So in that sense, absolutely one can reproduce it. In that paper, what Professor Kaczynski did was that he created about 40 vignettes, something like that, which were meant to emulate the original tests that were used with children, like the Sally-Ann test that we already discussed today, but also another test it's sometimes known as the Smarties test. And if you don't mind, I'll take just a second to explain it because it's important for what's coming next. So in the original Smarties test, you hold up a box it seems pretty obvious what's inside. It's a box of crayons. And you ask the child what's in it, and they say crayons. And then you open it and you show that, in fact, there's candy inside, right? There's Smarties. And they're surprised, right? This is the unexpected content task. But then you close the box and you ask them, like, hey, what if I ask your other friend, right, Mary or whatever, if I bring her in and I ask her what's inside, what will she think is inside? And 4-year-olds can say she'll think that there are crayons, even though they know that there are Smarties inside. But 3-year-olds think like, well, she'll say Smarties. So like what they seem to know, they seem to expect other people will think as well. So he took a bunch of variations on the Sally-Ann task, and now he couldn't. This is, by the way, a problem with current models, right? He couldn't use the original Sally-Ann task because these models have eaten up the internet. So this is one of the most common tests. There's tens of thousands of papers like writing about this stuff. So certainly it could just do some statistical matching on those things. He created equivalents of them. For example, here's a bag. It's opaque. You can't see what's inside. In fact, there is popcorn in the bag, but there's a label on it that confusingly says that there's chocolate in the bag. Here comes Sam. Sam has never seen the bag before. Sam reads what's on the label. What does Sam think is in the bag? And the model, not all models, but some of these models say chocolates, right? So you can get them to complete the sentence. In the bag there is, and it'll say popcorn. Sam believes in the bag there is, and it'll say chocolate. Okay, so it can correctly report on what's inside, and it can correctly report correctly. I'm doing scare quotes. Can correctly report that that Sam believes in the bag there are chocolates. So 40 variations on that. Professor Kaczynski found that GPT 3.5 can correctly do about 95% of these things, or above 90% or something. I don't remember the exact numbers, but something to that effect. Okay, so just setting the background. What this paper that you mentioned was about was to generate sort of alterations to those things, which we would consider pretty trivial and the kind of stuff that adults would certainly not have a problem with, in the spirit of adversarial changes that you might find in images, for example, right? Like, wow, this thing can recognize it's a cat, but we change one pixel and now it thinks it's a school bus, right? Which is, I'm sure that people have arguments about what these adversarial images mean. To me, that's very suggestive that whatever this thing is doing, it's not human-like visual recognition. It's schmeckignition or something like that. But it's not visual recognition a la humans. So similarly, I created these sort of small variations that I don't think should be a problem for adults. Like, let's say the bag is transparent, right? You can see what's inside, but it's still, GPT 3.5 completes it to be, that Sam thinks there's chocolates. What if Sam can't read? Doesn't matter what she sees on the label, right? Chocolates. What if Sam's friend told her that there's popcorn inside? You'll go into another room and there'll be a label. Forget the label. Sam believes her friend. Sam goes into the room. She sees the label, chocolates. What if Sam filled the bag with popcorn, closed the bag, took a label, wrote chocolate on it, slapped it on the bag, read the label? What does she think is inside? Chocolates, right? So to us, to me and other people, not everyone, but at least to some of us, that suggests that these things are not robust. And I'm not trying to claim, to be clear, I'm already heading off maybe another point of discussion. I'm sorry if I'm jumping ahead, but
not at all.
I don't mean to suggest that the variations are robust. Okay, so I don't mean to suggest that like GPT-4 will definitely fail on exactly this variation. Kind of like with the pixel, right? We're not claiming that pixel is the problem. We're saying that given that this thing is not robust, we will be able to find a pixel that'll fool it. So similarly here, I think that like if these things are not robust, we will be able to find a variation that'll fool it. But I'm not claiming that the variations in and of themselves are robust. So this thing just got tripped up basically by all these variations, which to me suggests that it didn't really pick up robust theory of mind.
And can you speak to the, I guess, how much you were able to damage the result? If it's 90+% adding in some of these things like transparent bags, how often can you get the system to trip up?
I guess I introduced 4 variations to the Smarties task and 4 variations to the Sally Ann version of the task. And for each one, there were 2 completions where I was just following in the footsteps of the previous paper. The previous paper had 2 completions, one being Sam believes in the bag there is, and the other one being Sam is delighted to have found the bag. She loves eating, whatever. So there's 16 things there. And it's tripped up by all 16, although I should say that since then, I had an email exchange with Professor Kuczynski where he pointed out that one of these things, and this is in the updated archive version, I should say. So like, look, I tried going over your things, and for one of them, for the bag, I forget if it's the transparent one or one of the bag variations, for one of the numbers you report, they're not correct. So you say that it's chocolate with some probability in it, or you say it's chocolate and in fact it's popcorn. And I went back and I checked, and he's right. Like those weren't like I tried to do it and I didn't get the numbers that I put in the original archive paper. And I couldn't figure out like why, right? I just copy pasted the numbers, and obviously I'll update it that this isn't true. So you could say 15 out of 16 trip it up. But then I tried to figure out like what was the problem? Like why was this? Because again, I was just doing copy paste. Like I couldn't figure out what the issue was. And I went back to some of the original version. I realized that I had a double space between the full stop and Sam. And when you do the double spacing, now it flips. So does that mean that it's 16 out of 16 or 15 out of 16? I don't know. It's hard to say because certainly I was doing a search process, right, of trying to trip it up. And I tried several different things, right? So one should probably also keep track of like the search process of trying to trip it up, right? You try to change the names, which by the way has tripped up previous models, right? Like you change Sam to John and you change popcorn to blizzards or something like that. And that would trip it up. And with GPT 3.5, let's say, I think it didn't for some of those things. What counts as these variations and how hard it is to trip it up is a good question.
Well, the extra space example is, I think, especially interesting. I know there's a great debate amongst typists whether you put 2 spaces or 1.
Oh boy.
Could that decision ruin our ability to invent AGI?
Or maybe we'll be saved by that, right? The Terminator will rise up and we'll have like the double space or something. And
that's how we'll beat him.
Yeah. I don't mean to make too much of that, right? And I don't know that GPT-4 is floored by those things, but I didn't even think to try that.
Yeah.
This was like a later discovery following this email.
Yeah.
So
much more rudimentary of an attack than your other sort of sophisticated thoughts on it.
For any one of those vignettes, one can find a variation that'll trip it up. And I think that this was true also. So again, I recommend to your listeners this recent paper that came out that was spearheaded by Natalie Shapira. This was again like yesterday, where they do this more systematically and also with GPT-4. So my variations paper, they call it, by the way, like the Ullman variations, which I love, and I'm putting on my CV because it makes me feel like Bach, right? Like the Ullman variations. But so they did it more systematically and with GPT-4, but they walk away with very similar conclusions, like that you can basically trip this thing up. And so it doesn't seem robust.
So is this the right standard? Should we think that enough time researching and investing in building better and better large language models will eventually gain this property? Or is it inappropriate to think that next word prediction should exhibit theory of mind?
I don't know. You're cutting to the heart of like some really big discussions that are happening right now in cognitive science and AI. And I don't think that there's like a single answer here. So it's not even a two-sided debate. It's like a multi-dimensional, multi-front debate, and there's smart people on all sides of it. I say that not because I don't have opinions. I have opinions on this stuff, but I just want to clarify that like if we had proof, either mathematical or otherwise, we wouldn't be arguing about this stuff. And the fact that we're arguing about it is suggestive. I shouldn't bet against deep learning. And they certainly have on their side something like, look, these models, whether next step prediction, transformers, some of these other ones, like they're all Turing complete. So if in principle there's an input and an output function, and the right algorithm is whatever it is people are using, and we're not, as AI people, we're not even committed to what algorithm people are using. Maybe they're using inverse planning, maybe they're using something else, maybe they're using something much dumber. Whatever the algorithm is, this thing is Turing complete, and it will find the right approximation to the thing that people are doing or should be doing or things like that. And yeah, maybe from next step prediction, like maybe in order to do next step prediction, maybe you need to construct a model of the world, right? Like maybe that's the best way of doing next step prediction. So maybe. I don't want to say categorically that that's impossible. But what I've seen over the last 15 years is a repeating dynamic with both, these bottom-up things in vision and things like that, and now with these large language models, whether it's transformers or other things or GANs, again and again and again, there's this dynamic of here's a benchmark, right? Like AI person, like give me a benchmark, right? And I'll try to pass the benchmark. You give them a benchmark, and then they pass the benchmark using a lot more data than maybe you expected is even possible, right? Like, what's a thing only humans you think can do? And it's like, I don't know, image captioning, right? Like try to look at an image and actually tell me what the story is that's going on there. And then they take a bazillion images and a bazillion descriptions of those images, and they achieve 95% on that, which is surprising and wowie and good for them. And like you can sell that for $1 billion. So that's like a serious advance, right? But then you examine it, right? Like, when I say there's a lot of people doing this. You examine it like, wait a minute. Like, yeah, when it sees like an image of children in the park playing Frisbee, it says children in the park playing Frisbee. That's amazing, right? Maybe you can even show that was never an image that it actually saw. But now when you show like children standing on a Frisbee, they're like children in the park playing Frisbee. What about children eating a Frisbee? Children in the park playing Frisbee. What about a Frisbee throwing the children, right? Like children in the park playing Frisbee. You're like, wait a minute, this thing is actually like not... Our tendency is to look at it, the success, and say this thing is smart and it's doing it in a human-like way. And then you push back against it and you find these sort of failure modes that seem to suggest that, in fact, it's doing something much sillier than you thought that it was doing to begin with. And the response to that is usually like, oh, it's smart, but not in a human-like way. It's an alien intelligence. And, birds fly and airplanes fly, but birds don't fly like airplanes fly. It's doing some sort of clever, non-human-like thing. And you keep pushing back against it. This is, by the way, incredibly self-backs, again, smart people on all sides here, but I'm constructing a slightly straw man here. But you push back against that. Like, no, this is silly. Like, this is not human-like, nor is it intelligent. Like, oh, yeah, it's pretty dumb, but humans are dumb, too. And you're like, no, actually, look, they're clever in this way and that way. And they're like, yeah, all right, but I'm just trying to build a better phone. So, I have nothing against that, right? And I'm not describing any real person here. I'm describing a dynamic that I'm kind of concerned about, maybe. And you see that dynamic again and again and again over the last 15 years. And so to me, I think that depending on your goals, if we're trying to build better phones, and we say that from the beginning, sure, I think we've made a lot of progress. And I think that like maybe large data, it's amazing what you can do without understanding. And I mean both sides of that. And I'm just feeling that more and more over the last few years, both sides of it. It is amazing. But it's amazing what you can do without understanding. I don't know that I would say, like, I don't mean to be like the czar of, I don't mean to dictate what people should do. People should keep doing whatever they're interested in. And I think we made a lot of progress. I'm sure that people will continue to push more data and large language models and whatever models they come up with, as long as it seems to be achieving some sort of progress. And they should keep doing it. And it doesn't matter, in fact, if I say that they should or shouldn't. Like, it doesn't whatever. They'll keep doing it whether they should or shouldn't. But I think that's okay. But I do think in the sense of, are we trying to create something that is human-like and human level and generalizes like humans and has human-like common sense? I don't think that the current path is the ultimate solution. I don't think that we should throw it away. I think that humans certainly have something like they have. Human intelligence contains multitudes. We don't have a single algorithm. We have multiple modules in our minds, I think. And it's certainly possible that one of them is something that's close to a large language model. That's possible. So in that sense, I think that we should take these things very seriously. But I don't think that it's the only thing that we should be doing. That's incredibly cowardly, right? Like, who would argue with that? Who would say, like, no? Well, actually, never mind. As soon as I said that, I can imagine some people are like, no, we figured it out. We keep doing this stuff and it'll be okay. But yeah.
As you point out, people are going to pursue lots of avenues in exploring AI. One will be language models. Maybe there's some other paths we don't even know about yet. Obviously, pursuing any path, there'll be some amount of progress. But if we truly want to achieve some theory of mind that's comparable to what we think we see in adult humans, is that going to require a new theory or just application of the current theories?
I don't know. I don't mean to make prognostications, right? Like, smarter people than me have said that it's impossible to really predict what's going to happen like 5 years in the future with this stuff. So the short answer is I don't know. And if that's the only thing you take away from it, it's I don't know. At the same time, I don't mean to be dishonest, right? Like in the sense of like, I have views, right? Like I wouldn't be doing the things I'm doing if I didn't have views. So let me honestly communicate my views, but to clarify that they have confidence intervals on them, big confidence intervals in the sense of like big means I'm not sure, right? I'm willing to be persuaded, and then the people should try all sorts of stuff. So I think that specifically for theory of mind and some of these other common sense reasoning things that I'm particularly interested in, like intuitive physics and intuitive psychology and some of this other stuff on intuitive biology, I don't think that we need a radical reorganization of some of the stuff that's already out there. I do think that it's going to take a serious push in the same way that there's been like, billions and billions of dollars and thousands of PhDs spent on this stuff, right? Like, so I do think it's going to take billions and billions of dollars and thousands of PhDs on taking some ideas coming out of computational cognitive science, out of probabilistic generative models and program learning and program synthesis and neurosymbolic stuff, ideas that are out there, right? Like ideas that people have been pushing and writing papers on and things like that. It's not new, but I don't think there's been like a push for billion-dollar attempts at neurosymbolic program synthesis and inverting probabilistic generative models and things like that. So I think marrying those with more neural networky ideas is the way to go. And again, I'm not. There's a lot of people saying that. And I think that you're also seeing like a convergence, right? So the people who were maybe 10 years ago, they were further away. The people who are more like probabilistic programming and program inference and, over here. And the people are like, no, neural networks, over here, or something like that. And now it's like, the probabilistic programming people are like, yeah, probabilistic programming. But at the end of that program, that probabilistic generative model, there's a neural network. And the people who are doing like neural networks are like, yeah, neural network. But at the end of that neural network, what we're really trying to figure out is a causal model. And so I think that they'll, they're already meeting somewhat halfway. And I think that, the reasonable, smart people that I know are thinking along these lines, of course. And so, yeah.
Well, Tomor, is there anywhere listeners can follow you and your work online?
Yeah. So I'm, for now, on Twitter. Maybe it's becoming more and more embarrassing to say that. Not that it was ever not embarrassing. But yeah, it's just my name, Tomor Ullman, at Tomor Ullman on Twitter. You can find me also. I have a website where I keep these, my publications and things like that. You're welcome to write me emails as well, tomorUllman@gmail.com. I don't know that I can answer all of them, but I'm happy to get emails. And yeah, maybe I'll move off of Twitter once we can. But yeah.
Sounds good. We'll have links to all the above in the show notes for people to follow up.
Great.
And thank you so much for taking the time to come on and share your work.
Thank you so much for having me. This was a great conversation. I really appreciate the opportunity.
Well, that concludes this installment of Data Skeptic Machine Intelligence. Join us next week when we ask the question, can artificial general intelligence be safe?